Hello dear colleagues, today I present work on the topic transfer training tools and methods for diagnostic tasks. We will talk about the diagnostics task as an example of medical diagnostics. Transfer machine learning offers significant advantages for medical diagnostics, especially when dealing with the limited datasets. This approach allows models pre-training on large datasets to be adapted for specific medical tasks, reducing development time and improving accuracy. Generally, we talk about using transfer training tools based on some pre-training models. For example, models which based on neural networks. When we talk about the main advantages of using technology of transfer learning, we usually talk about fast adaptation, less data needed, and better generalization. Fast adaptation because we're using pre-training models, less data needed because we have the model which were training on large data set, and then when we need to make some adaptation of this model, we can use less data. And what about the better generalization? Usually transfer learning work with deep neural networks, so they training on large shared data sets, which contain very huge amount of knowledge about the common future. And then we work with less data sets, small data sets, and transfer learning methods make the model more adaptation for some special sets and from some special tasks from the big to the small, make it is more generalization. When we talk and compare classical machine learning with transfer technologies, we can represent this as a table, and as you see, usually for transfer machine learning we use smaller data sets. The training time is shorter, the computing resource are less. We don't need so powerful computer resources. And what is more interesting, usually we talk about that transfer machine learning have lower risks of overfitting, overlearning. In this research, we use different deep neural networks. We start with more classical in this set deep neural network. It was convolution network, neural networks. Then we work with DenseNet and ResNet. All these deep neural networks usually use for work with images, with some image information, and in the medical tasks, usually we talk about some X-rays or some result of tomography and so on. So this is images, and for work with it, we usually work with neural networks which demonstrate a not bad result in these tasks. What is more, we use some others deep neural networks. For example, it was InceptionNet and net with some filters, VGG. It is one of the classical interpretation of these networks with 16 layers. So these types of deep neural networks demonstrate good result with working with images too, so we use it to compare in the future the result. About dataset, it is a very well-known dataset, pneumonia detection. You can see the main information about this dataset. And you can see the accuracy of different neural networks working with this dataset using the transfer learning. And it is interesting that usually when we talk about the using of CNN, we talk that this is, in nowadays, this is a basic deep neural network architecture. But as you can see, the result of CNN, one of the most better result. The good result also demonstrate DenseNet, but in this slide you can see the compare of training accuracy and the testing accuracy, and you can see that the difference in the training and the testing accuracy for the DenseNet are bigger than in the case of using of CNN. I mean this difference. When we talk about such difference in the case of using some artificial intelligence technique for human tasks, like the healthcare, like the safety of people, we can't use approach which demonstrate so big differences in the training and in the testing sets. But why the topologies of deep neural network, which usually demonstrate better result in the working with images, demonstrate such low results? One of the general ideas that in this case we work with the X-rays, and the X-rays it's very special images, and usually the accuracy of images in X-rays are not so good, so it can be a problem for the network which usually work with high resolved images, high quality images, and so on. But as you can see, the work with CNN demonstrate not bad result, and in the future it can be adapted, maybe using different images, using different approaches to bring this technology for the others topologies also. This is what we talked previously about why such situation could be. And there's some conclusion and the future directions of the work. We can say that transfer learning, it is very interesting approach when we talk about some adaptation of the neural network. Usually we talk that some methods which based on neural evolution usually are better for the make or more universal approach or more approach for the task. But when we talk about to make from one solution the list of solutions for different specific tasks, we can use transfer learning because it is more faster, it is lower resources needed, So in the future, working with technologies of transfer learning and combining the different methods of transfer learning could demonstrate a better result. In this is all. I'm thank you for your attention.